Hello everyone. In this session we are going to discuss about extended features of the ER diagram. So sometimes the ER diagram unable to describe all the things within that structure. So we need some additional features. So we are going to discuss that extended features of the ER diagram in this session, like generalization, specialization and aggregation. These concepts slightly elaborate the schema. When the schemas or situation is going to be a bigger thing, in that cases, how to represent those features under the ER diagram. So if you are just taking the university, considering the many persons may be involved, faculty, student, working people, non-teaching, teaching people, everyone. So they are having the some common attributes like their name, ID, address, joining date, etc. So that we can maintain as a entity cert as a person. Under the person we can extend these are the student, faculties, teaching faculty, non-teaching faculty, etc. level. So how to specify these things? Under the entity set, the person may be further classified as an employee and then student. Then further the employee, it may be a teaching employee or non-teaching employee. Okay, so the higher level entities having the common attributes, the person is having their common attributes. Additionally, the extended classified entities may having their own attribute. A specialization, the both employees and then student described by a set of attributes that including the all the attributes of entity set of the person, and similarly they may have the additional attribute. Example, name and address and then personal data is both are common for employee and then student. Additionally, for the employees they may having belongs to the department, joining date and then working procedure, that will be different. For the student they are having the marks, grade. So these are all the attributes, additional or individual attribute of the students. So like that you can able to categorize for the graduation, undergraduate students. Under the student you may further extend it as an undergraduate and then postgraduate. Each and every cases they have some common attribute and they will having the individual attributes too. So it is the flow like it's a tree structures, the top level and then further it is classified as a next level and then further it's going to be classified as a next level. So each and every level they having their own set of attributes and then additional attributes also they are having the extended entities. So this is the diagrammatic representation of the specialization depicted by the hollow arrowhead pointed from the specialized entity to the other entity. Here the person is going to be categorized as a two, employee and then student. Person is having the common attribute of ID, name and address. Additionally, the individual attribute, the employee having a salary and student has a fees. Similarly, the employee is further divided as a teaching faculty or non-teaching faculty, the next level you get. So it having a is a relationship. The faculty is the employee and the employee is a person. Like that it having the is a relationship. Generalization is a refinement from the initial entity set into the successive level of entity subgrouping represent to the top-down design in the which distinct or made explicit. But the design of process may also proceed in a bottom-up manner. So first we are just going to be analyzing the common features, and it is synthesized into the higher level entity set. So the database designer may have first identified the faculty entity segments, what are all the attributes they are having. Similarly, the secretary entity segments, what are all the attributes they need to follow. The previous example, the employee is categorized as the two entities, a faculty and then secretary, or otherwise a teaching or non-teaching. So we need to first identify their individual attributes. Then it is a common. Then it is next level. So it is a bottom-up manner we are just proceeding. So there are some similarities between the faculty entity and then secretary entity. So it means several attributes that are conceptually the same across the two entity set. So like the personal data, ID, name, salary, etc. So the generalization, it is expressing the common things. So it is containment, the relationship between the higher level entity and one more level, that is a lower level entities. Higher and lower level entities also designed by the super and then subclass category. So in that way we will be designing. Then attribute inheritance. Obviously when we are just having the relationship between the higher level entities and then lower level entities, the lower level entities having the inherited from your higher level entities. Like inheritance concepts, a parent and then child classes. The child class inherits all the characteristics from the parent, and also it is having their own individuality. The same thing here, the attribute inheritance will be applied. So the lower level entities are inherit the attributes from the higher level, and additionally they having some own level of the attributes too. The attribute inheritance, the higher level entity with the attributes and then relationship that all apply to its lower level entities, and lower level entities with some distinct features that only apply within a particular lower level, so that will not reflect in your higher level entity set. So this is the attribute inheritance. So the same example, ID, name and address. The person is a higher level, lower level is the employee and then student. The employees, it inherits all the person attributes. Employees has ID and name and then address. Additionally, the employee having its own extended attribute as salary. Similarly, the same thing is applicable for the student too. Aggregation, one of the main limitation of the ER diagram, that it can't express the relationship among the relationship. To illustrate this, we need to consider the ternary relationship. Here the project guide, it's a relation between the three entities: faculty, student and then project. Similarly, that it may be extended to the next level. So every month the reviews may be conducted, so the faculty may be entering the review reports, so another one entity is going to be involved. So in that cases, the four-way of the relationship is needed. So to combining which these things, so at that time it is not permitting like this. So using the ER model construction, the following ER diagram, it is representing redundant relationship. Again and again, the project is relevant to the review, and then faculty is reviewing, and then student is coming for the review. So the relationship is going to be redundant. To avoiding these things, we will just going for the aggregation. So we are just making that one as a superset, and based on that we will just making the relationship for the review. So here the best way the model to represent the aggregation is the abstraction through which the relationship treated as a higher level entities. And in this given example, the relationship set, it's a project guide is a one set, and then the reviewing is a another set, so that it may having the relationship like that. We are just setting the aggregation. So when the extended features will apply. The ER model, it having the in-depth knowledge of, or the schema level is going higher. In that cases we can't able to manipulating the entities and then relationship again and again. It will make the clumsiness. To avoid that, we will be applying these kind of the extended features like specialization, generalization and aggregation. So this will help us to show the ER diagram in a clear and crispy manner. Thank you.